So you've got 30 of these lights rated at 2080 watts of output. So that's how much light you get from them. And they're wired into a system operating at 208 volts. And they've got this power rating on them, 0.99. So the first thing you need to figure out is how much current is that going to draw. So your power rating formula is you take the power rating, and that's supposed to be the ratio between what you're getting, so like what's advertised by the machine to as its power output, divided by the voltage that you're running at, multiplied by the current you actually draw. So this one here in the bottom, that's the actual power consumption. So if you think about a light that's rated at 2080 watts, it's going to get fucking hot, and there'll be other sources of waste. So this down here, this is something you can measure. You know the machine's running at 208 volts, and then you can put your ammeter on it and see how much current it's actually drawing. And these two things multiplied together, voltage times current, gives you a power output. And that'll be the actual power consumed by the machine. So you can see how this number here, if you take the power that you're getting out, like useful power, right? So as light, if it's lights, divided by the power you're actually consuming, if this is less than 100%, then you have waste. So this number here, the smaller this gets, the less effective the thing is. So just to finish this off then, 2080 divided by 208 is just 10. You're going to do a little algebra. You pull the I up here. And then divide both sides by 0.99. And that gives you 10 divided by 0.99. It's 10.101010, etc. So that's how many amps of current this particular light needs to draw. This is aside from it being a three-phase system. This is just if you plugged it into your wall, that's how much current it draws. So I'm gonna write that here. Where's my usable screen space there? Okay, so they are 10.10 amps each. Okay, so the same calculation done on your light bulbs, the LED system. So it says in the question that you have a power factor of 0.5, and they are rated at 120 watts, and you are attaching it to a 120 volt system, and I don't know how much current is going through. So that's 50%, right? So the actual power you're getting as light is only half of what you're actually providing. That's what this number means. So if I pop that up there, well, 120 divided by 120 is just gone. Or 120 divided by 20 is 1. Same little bit of algebra. Multiply both sides by I, so it's not in the bottom of that fraction, and then divide by 0.5. 1 by 0.5 is 2. So these were the motorized ones. The LED ones, each is drawing 2 amps of current. So that has nothing to do with the Y. That's just how much current they're going to draw based on their power ratings. So the Y, I guess they draw it like this in a circuit diagram. That's why they call it a Y. So there's 3 terminals on your Y, and then there's a 4th one in the center here. And I think the idea is that this one in the center is the neutral, and then this is phase A, phase B, and phase C. So each of these are operating at the voltage between any one of them and the neutral is 120 volts. But if it's set up this way as a balanced Y system, then the voltage between any two terminals, between these two or these two or these two, is 208 volts. So, and that why doesn't matter. That's just a fact that the voltage between any two terminals is 208, and between these two is 120. So if you're going to go and you're going to hook up all of these silly lights here, I think it said in the question that you have 90 of them. So those 90 up here, 90 of these, you're going to attach, in order to balance it, you have to attach 30 of them to this terminal, 30 of them to that terminal, and 30 to that terminal. So 30 of them at 2 amps each ends up being 60 amps. So the line coming in here, it's going to have 60 amps attached to it because of those LED lights, and it's just attached to this one. And then there'll be 60 amps going into this one or out of that one, and 60 amps into that one. So I've accounted for all of the LED lights, and they don't have to have anything fancy done to them because they're just attached to one pole. So because they're only attached to one, they just operate like anything you plug into your wall. It requires a certain amount of current, so off it goes. The other pieces, the motorized lights, it says that they need to operate at 208 volts. So they won't work if you attach to only one terminal. You have to attach to 2. So in this configuration, and this is you'd think that would be 240 volts, but it has something to do with how this thing is built, that there's only 208 across them. Again, it doesn't matter for this question, and I suspect not for the certification, because you're probably not going to be building these, you're just going to be working with them. So you just need to know that it's 208 across a Y like that. So if it's 208 volts across this, and they're 10.10 amps each, and you have 30 of them, that means you're going to have to attach 10 of them across these two, 10 of them across these two, and 10 of them across those two. So 10 of these would end up being 101 amps. So the way that works is you take that 101 amps for the one that you attach here. It's going to draw 101 amps. 10 lights will draw 101 amps from these two terminals. That means it's going to be 50 and a half from each. So when I attach onto here, it would be 50 and a half out that way, 50 and a half out that way. Now there's a weird little catch, because it's in a 3-phase system, that you need to draw more current than it says, because it's sharing across these posts. You don't have to take twice as much. You have to take, it's the square root of 3. Why? There are 3 poles. It's a Pythagorean relationship. It doesn't really matter. You just need to know that it's multiplied by root 3 anytime you're sharing the poles. So this thing here then, 101 amps, because there are 10 things at 10 amps, you have to scale that up by the square root of 3. Because you're starting to attach and draw from 2 poles instead of just from 1. So if I go and I calculate that, 101, no, that's square root of 3 times 101 is 174.9. Okay, now, so each one takes 10 amps. You're going to attach 10 of them on here. That would be 101 amps in total. Because you're drawing from different phases, you need to draw extra current. You need to draw this much more. So those 10 motors are going to pull 174.9, you call that 175 amps of current from these 2 poles. So that would be half from here, half from here. So that'd be 87.5. And then 87.5. So those 10 lights are drawing 87.5 amps from this pole and 87.5 from that pole. Now the next 10 lights you're going to put across these two terminals here. So these 2 terminals are going to have 10 lights at 10 amps for a total of 100. Scale it up because you're drawing from 2 poles instead of just 1 to 175. Share it across these 2 posts means another 87.5 from this one and 87.5 from this one. And the final 10 you're going to be wiring across these poles. So 10 lights at 10 amps for a total of 101. Scaled up because you're drawing from these 2 poles is 175. Split across 2 poles is 87.5. So when it asks you across each phase, it's asking across each of these things. And if it's balanced, then they all have to equal each other. So on this particular phase, for example, then, you needed 60 amps to pay for the LEDs on that phase. And you needed 87.5 to pay for half of the motorized lights on these 2 pins, and 87.5 to pay for the motorized lights on these 2 pins, for a total of 87 and 87 is 175, plus 60 is 235. So you just took this plus this plus this, 87.5, 87.5. 60 for a total of 235 amps. There you go.